Hello, and welcome to this TDDD27 personal code demo. My name is Elliot Norlander, and this is my personal code demo for the reps and sets workout tracker that me and my buddy Jacob has created. So I want to start off by just showcasing the file structure here. We have a pretty simple back-end front-end file structure where we have collected the back-end files in one folder and the front-end files in one folder. And as you can see here, we have then a SRC or source directory, which we have then divided into a database and a routing folder. The database folder contains all the middleware for the database, and the routes contain the backend routes that the front end then users. Looking over on the front end, we also have a source folder, of course, which we have then divided into all the pages as well as a components folder. And we use this component folder to store all of our reusable components that we use throughout the project. Just quickly gonna show you how to start the project as well. To start, just type npm start in the front end directory, and then for the backend you would just go to the backend and start by using npx nodemon src/index.typescript. So that's how you start the project as well. If we then take a closer look at the database here, we have 3 files open right now. So we have the schema, we have init and the connection. And if we look at the schema file here, obviously we have 4 tables now. So we have users, workouts, exercises, and the calendar table. Looking closer at the user table, we store pretty typical things in our opinion, such as like an ID, the username, first and last name, email, password, as well as a timestamp that we use to reference in the profile page. As well, like the workouts table stores the things which are necessary to display the necessary information for a workout. Same as for exercises, where things like exercise name, number of sets, etc. Shows up. And this also goes for the calendar table, as you can see at the very bottom there. Looking over at the init file, this is where we actually establish the database. So what we do here is we wait for a connection from the connect.ts file. Yeah, you got it right there. And then we fetch the schema and create a database from that database schema that we just saw. So looking closer at the backend here, if we start at the index, which is the source for the backend, this basically sets up a Express.js backend server. So what we do here is, well, first we import a lot of things, obviously, and we load the environment variables. We set up CORS and JSON parsing for the requests, which is mandatory, of course. And then we have our backend routes. So here we have the user route, workout route, exercises, and the calendar route. So we then parse this by using different files, which we have up here, as you can see. And we will look closer into each one of them as well. Then we also set the root route to the index or slash, and then also like set a very a small message just to indicate that the backend is actually running and functioning as it should when we start it up. If we take a closer look at the users routes, we have a bunch of them, obviously. And my idea is here that I will just look closer into one of them because the rest of them follow sort of the same like path, or how you should say. They follow the same way of working, but they do different things obviously. But looking closer at the add a new user route, here we obviously, first of all, we extract the data from the request and validate it. Otherwise we return a 400 bad request message. Then we instantly try to hash the password, and here we use a salt round of 10 for extra security. Then we insert the user into the database with the hashed password then, of course. And if something here breaks or fails, then we return some error messages. Otherwise, we respond with the 201 created error message, or it's not an error message, but response message. And as I said, the other user routes follow this sort of like template. If we hop back to the index file and then look closer at the workout routes, which are the routes used by the workout management system in the application, we only have 3 requests or 3 routes here. So we have a post to add a new workout, we have a get to get all the workouts for a user, and we have a get for the number of workouts per week for the current user. And this last one is actually used to display the graph or the per week exercise graph on the user dashboard that I mentioned in the joint screencast of the project. And with that said, let's just hop on over to the exercise routes. And one thing we utilize here is the use of a interface to specify how the incoming JSON file structures should look like, and this we don't use in the user routes, but I believe we use it in the workout routes, but I think I forgot to mention that. And here we really only have 2 routes. We have a get to get all the exercises, and we also have a post to add an exercise. And as I said before, this really follows the previous structure for this type of request. Lastly, if we hop on over to the calendar routes, we have 4 routes here. A get to fetch all calendar events. We have a post to add a new workout to the calendar. We have a put to update the workout date in the calendar, and this is utilized for the drag and drop feature that we have implemented. And we also have a delete to remove a workout from the calendar. So if we direct our attention from the backend to the frontend now, as I mentioned before, we have a similar structure where we have an src folder, and here we actually have all of our pages. As you can see, we have like for instance app.typescript, which is the here we define the main entry point for the application, and as you can see, we use React Router to set which view or which page to showcase depending on the URL. And my thinking here is that I won't necessarily go into each and every page in detail because it's just a bunch of front-end framework utilization, and in my opinion that is not really that interesting, but I will do a breakdown of the structure and how it functions. So if we look closer here at the dashboard file, which obviously shows the dashboard, it first of all contains a lot of the sort of backend logic or client logic to get the necessary information, which is to be displayed in the dashboard. So the name of the user, total number of worked out minutes, the workouts per week for the graph, total number of calories burned, etc. And if we go down to the very bottom here, we can show what the view actually looks like. So here we can obviously see the pros of using a predefined component, since we can just pass on the data we want to display, and we don't need to have all of the logic for each separate component in just this file, and instead it can be reused by other pages, and this we will also see later in this demo as well. And if we jump over to the calendar page of the application, we can really see how utilizing a component here is so efficient. So what we do here is just actually referencing a custom component called workout calendar, which handles all of the both backend and front-end logic of the calendar, which is just really great, as I said before. And what we utilize here is an event handler to handle things like when we create, or when we tap to create a new workout, or drag and drop a workout to move it, or click a workout to delete it. And this just makes it really easy to be able to handle all the different types of possible events, and then mapping these events to proper backend logic in our server logic. And yeah, that's just one of the really good parts about writing a component like this, because now if we want to reference or use this in another part of this project, we can just reuse this, and we don't have to recreate all of the code again. Oh, and I should probably mention that we use a JavaScript library called full calendar to display this calendar, and we actually use the React wrapper for this component library as well. And speaking of components, I thought I will just do a cherry pick of some of the components we have created during this project. So if we, for instance, look at the dashboard graph, that's obviously this big graph on the dashboard here. And if we look at something like, let's say, the header banner, that's for the header banner in the top there. So then we can utilize the fetching of the name, etc. In the component. The dashboard display, we use 3 times on the dashboard as well to display some core information. Show exercises we have there. If we look at the workout calendar, that's obviously the large calendar that I mentioned before. The workout list is the long list of workouts, so this one right here. So lastly, I just wanted to go over a large, or quite large, component that we have written called inbox. That is its current name at least, but something, or a better name would probably be something like calendar sync or something like that. But the basic idea of this is that the user may have all the workouts in their calendar system that aren't yet in their current workout stats. So this component compares both of them and lets users manually sync the missing ones. And it's implemented as a modal using React.js pop-up. So when I click this button, sync with calendar, it opens the modal and triggers a fetch to load all workouts from the calendar. And inside fetch calendar workouts, we can fetch from the API, and we can then compare the fetched workouts against the existing ones passed in via props to find the unmatched workouts. And those basically are the ones that exist in the calendar but not in the current workout stats. And this is actually done by comparing the workout date and the workout type fields. So
each unmatched workout is displayed with its type and date, and below that the user can optionally edit the burnt calories or the duration, and then they can press sync to sync